Hello, everybody. My name is Elizabeth Brown. I'm a PhD student at UNC Chapel Hill in public policy. I'm going to be talking about my summer research project right now, but just for a little bit of background, just to motivate my research interest in general. I started in economics, and I'm really interested in that nexus of environment and energy problems in international development. So I had seen this typical pattern that as people get wealthier, there's this trade-off with more emissions, more pollution, more consumption, which is good, but it has those drawbacks. So broadly, I'm curious about where there might be opportunities to get the best of both worlds, so to speak. And that has led me to an interest in off-grid renewable energy and partially motivated this particular project. As we heard in some panels yesterday, some of the poorest people in the world live very far from existing electrical grids. This work in particular is focused in Papua New Guinea, which is a fairly poor country, but it has this specific challenge with grid electrification, which is that it's an extremely low density country. The terrain is really challenging to navigate. There's lots of mountains, jungles, hundreds of small outlying islands, and it's very expensive to extend a grid to populations that are small but scattered out like that. Off-grid solar products are a developing market here, so people are buying a lantern or like a small array of solar panels, but we are really interested in getting more universal electricity access, which is going to mean more investment, particularly in mini-grids, which some research says is going to be necessary to meet those targets. So, and then this site context gives a specific challenge to meeting those needs. So the same factors that made it hard to extend the grid itself make it really hard to get surveyors or engineers out to a site to actually estimate how much material would be needed, like what's the specific layout of a grid going to be at this site. And that makes it hard to estimate how much one of these projects will cost to install, and that makes it hard to go to a funder and ask for support if you don't know how much you're asking for, and that perpetuates the cycle of people not having access to electricity. So my project builds on several existing projects working on this challenge. So this is just a very small contribution to a lot of other collaborators' work. The first piece that I'm building off of is, you can see on this map, this is very high resolution population and demand modeling. So we have for every 2 square kilometer cell in the country a good estimate of how much demand might there be at this site, and then what might be the most efficient way of electrifying people, either with standalone solar products, extending the grid, or as you can see, these dark blue spots, those would be good mini-grid places based on how many people are there, what the demand is, and the distance from an existing grid. And so we know where mini-grids should probably get built, and then the next step is figuring out what a mini-grid should actually look like at one of these sites. So the other piece of existing work that I'm building off of most closely is a network mapping tool that my colleagues, including Candace Henry, she was here earlier, have been working on developing. So the idea here is to take an aerial image of a community like this and draw the most efficient transmission network between all of the buildings just from the image, so the shortest distance that avoids obstacles. And their work isn't published yet, so just as a mock-up, you might take an image like this and draw a network like that on top of it. And from this, we know things like roughly how much length of which types of transmission lines you might need, how many poles, how many meters at houses, and that will let us get a rough estimate of the installation costs, which would make it much easier to go to a developer and say, can we get some money for this? And the challenge with this work, which is where I've come in to help, is that all of the buildings in these images so far have needed to be hand labeled. So we have economists and engineers sitting there and looking at the picture and saying, okay, that's where the building is, that's what we need to connect. And that makes it really hard to take this tool and hand it off to a community member, an investor, somebody who works at a utility, anyone else who would be interested. So we're really trying to get an out-of-the-box model that works. And so I've been trying to automate that building detection, which is have been a challenge for me. This is all pretty new to me. My background is more the policy side, so this was really an opportunity for me to learn how to use Python. Going okay so far. But I've been using pre-trained models mostly so far, and then publicly available medium resolution satellite imagery. So here's an example of just one model. This is the segment anything model that comes out of the box, and you can see it's user interactive. and it's doing an okay job at identifying where some of the buildings are. You can see it doesn't work perfectly just yet for imagery in this context, so there's more work to be done training that. But there does exist some high-resolution drone imagery that's already been captured. So there have been missions that flown out and looked at these communities and taken those images and validated them on the ground, which I'm working on getting access to, and I can use that to validate the models that I've been running on these publicly available data sets and this public imagery. And I think hopefully either way, no matter how the results of that modeling goes, this could still be useful. So if I can get a model that works pretty well on the freely available imagery, that says as these communities develop, as the buildings change, we don't necessarily need to go fly an expensive drone mission. We can use this cheaper method, and that could help us move this along even faster. And then even if it doesn't work, then that's good justification for going to the expense of running a drone mission. So hopefully it'll still be worth it either way. And then just to wrap up, there's two broad future questions that I'm interested in looking at. First of all, how different would it be in terms of cost estimates to use medium resolution or high resolution imagery? So if the goal is to get a ballpark cost estimate, and I'm identifying buildings, okay, is that still getting an estimate that's pretty close? Is it worth it to get the extra high resolution data? What's the trade-off there? And then hopefully this work will at some point lead to actual mini grids getting built, and we could have some real world actual cost data to benchmark our progress. Thanks so much.